Hi class, in this video we're going to be talking about misrepresenting data. So to misrepresent data is to make it misleading. In this case, we have an example here. What is wrong with this data here? So this is the results of Matthew's test shown in a bar graph. This is his score here from 0 to 70%, it looks like. And these are the results of test 1, test 2, test 3, and test 4. Now for test 1, it says he scored 60%. And then test 2, 65, test 3, 68, and then test 4, 69%. So in this case, what is wrong with it? Well, if you want to pause the video and then come back to it, you can. But what's wrong with it here is there is a line break right here. That's called a line break. So basically, a line break, it manipulates the consistent pattern that the y-axis is going up by in this case. So for example, look at it here. From 0 to 60, I went up by plus 60. But from 60 to 62, I went up by plus 2. Notice how the size difference of the squares are the same, but one is going up by 60 and one is going up by 2. So you see the pattern here isn't consistent. I'm not going up by a consistent pattern for my y-axis, and not doing so would actually manipulate my data. So if I were to not include the line break and to make consistent patterns, look at this graph here. This is Matthew's test score with a consistent pattern on the y-axis. Notice how it looks like he's not improving as much compared to when I manipulated my data with the line break. It looks like he's actually improving a lot from test 1 to test 4. But if you actually just make the intervals of the y-axis consistently going up by 10 each time, so that it's consistent all the time, it doesn't look like he's improving as much anymore, does it? And that's what it means to misrepresent data. So here, what's wrong with it is the line break. They're manipulating the intervals of the y-axis, so it's not going up by a consistent pattern. Hence why the data is manipulated, such that it looks like Matthew is improving a lot more than he needs to be. Now, another example of this is what's wrong with this data here. This is a line graph. So this is the temperature on a hot day. Here's the temperature from 0 degrees to 31 degrees Celsius. And this is the time of day in which the temperature occurs. So at 8 a.m., the temperature is 24 degrees. At 10 a.m., it is 26 degrees. At 12 p.m., it is 29 degrees. By 2 p.m., it's 31 degrees. And then by 4 p.m., it's cooling down. It's now 30 degrees, right? The thing that's wrong here is also the line break. Notice how the y-axis is not a consistent pattern. Right now, they're going up by 1 each time, but from 0 to 24, they're going up by 24. But they made it the same amount of space as from 24 to 25 and from 25 to 26, etc., etc. What this does is manipulates the data to show that the temperature increased by a lot. It's almost like it's exaggerating that your temperature increased at 8 a.m. all the way to 2 p.m. that it increased by a lot. But if you were to draw this to scale with the same consistent pattern on the y-axis, it doesn't look like the temperature actually increased as much as it should have. Now, here's another one. What is wrong with the data here? Graph A versus graph B. Now, if you think about it, both graph A and graph B are essentially the same. The only difference is the width of desktops for computer cells here. It's much wider, right? It's much wider, but even though it's wider, they're still selling 4,000 computer cells for desktops, and it's still 4,000 computer cells for desktops here for graph A. So what's the difference? Graph B is misleading, right? Graph B is misleading because by making the bars wider for desktops, they're hoping to confuse a viewer to make it seem like desktop cells were that much higher than laptops. But when you actually draw it to the original size, it looks like, yeah, it is. It's double, right? Because you sell 4,000 desktops and then you sell 2,000 laptops. Desktops are doubled. But by making it wider here, they're trying to say it's more than just double. They're trying to mislead the audience here. Now, here's another example of misleading data. This is a pictograph, right? So it says here, one pizza represents the choices of 10 people. So favorite lunch specials, one pizza represents 10 people. One macaroni and cheese dish here represents 10 people. And one hamburger represents 10 people. So what's the most popular lunch special? Well, it looks like hamburgers, right? Because one hamburger represents 10 people. So 1, 2, 3, 4, 5, 6, 7. This should be 70 people here. Macaroni and cheese is 40. And pizza is 30 people. Only 30 people like pizza. But what is the pictograph showing me? It's making the pizza unnecessarily large and wide and spreading it out. It makes it almost seem like, because they all end up at the same length here for length. They end up at the same length. It makes it seem like they're either all equal, or that you're basically like people are liking pizza more than they should be because they're exaggerating the size. Like notice how the pizza is much bigger than the macaroni and cheese, and then the macaroni and cheese is much bigger than the hamburgers, even though the hamburgers here um, should be way more. So if this was drawn consistently, wouldn't you agree? If this was drawn consistently, I would have pizza like this, and then I would have like macaroni and cheese or something like that. Excuse my drawing. And then the hamburgers, dot 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 dot. I would just go all the way out to draw like 7 hamburgers. So then it would look like there's actually more hamburgers, and then it's more realistic. So that's what's wrong with this data, is they're unnecessarily making the pictures bigger to mislead the audience. Now, what's wrong with the data here? Favorite ice cream. It shows the categories: vanilla, strawberry, and chocolate, and it shows the percentages. So what could possibly be wrong with this circle graph here? What's wrong with it is going to be it doesn't show the total, right? No total. If there is no total here, because usually for a circle graph, there has to be a total here for the total number of people that like ice cream. But if there's no total here, how can we find out how many people actually like vanilla ice cream, strawberry, or chocolate? There's no total, so I can't change these percentages to a decimal and multiply it by the total to get my actual answer. So it needs a total, right? It needs a total for number of people who chose their favorite ice cream. And hopefully that gives you an idea and some examples of what misleading data is and how they can be misleading.